Hello everyone, glad you decided to watch my talk about beautiful reactive web UIs, Ruby and you. Let's jump right into the topic and review the state of UI development for Rails developers in 2021. From a Rails developer perspective, UI development approaches might be classified like this. On the y-axis, we start with zero UI to a beautiful reactive UI. And on the x-axis, we measure developer happiness starting from low developer happiness, speaking of hustling with JavaScript and CSS, to high developer happiness caused by the beauty of Ruby. Implementing Ruby backend code is definitely a fun thing to do. But you don't get any UI out of it. Implementing Rails views, like ERB, Humble or Slim, probably added with some JavaScript sprinkles, might give you a good-looking, but often very static UI, with many full page reloads required. Additionally, you're definitely leaving your Ruby comfort zone here, jumping between Rails view files, CSS, and often widely distributed JavaScript snippets. Not too happy with that. And what about adding a second front-end application written in JavaScript? Well, have fun handling two states, the server-side and client-side state, synced manually via an API, causing headaches due to managing complex data flow and constantly switching between two programming languages and system architectures. Well, luckily, last year brought us tools like Hotwire and Stimulus Reflex, shipping some kind of reactivity abstraction, helping you to avoid tons of JavaScript and use more Rails again. Great. But I'm still missing the developer happiness I experienced when writing Ruby backend code. Things like object-oriented programming, class inheritance, modules, and simply a beautiful syntax leading to a readable and well-maintainable code base. Wouldn't it be cool to have all the benefits of Ruby while implementing beautiful reactive UIs? That's at least what I thought. By the way, if you end up down here, you're doing it wrong. But maybe it's time to introduce myself. So hi, I'm Jonas. I'm a full-stack software developer working for various clients in Germany, and I'm a huge fan of Rails. I was always working in a context where a small team with limited time and budget resources wanted or needed to deliver a lot. And that's where Ruby itself and Rails fitted in perfectly. Empower a small team to deliver big things, right? And I'm super honored to talk at RailsConf this year. I would have loved to meet all of you in person, but well, let's meet in Discord and get to know each other better after this talk. And by the way, I'm recording this talk in my small office in Dresden, and that's a picture of me moving in last summer. And I'm supported by my beloved espresso machine, producing great cappuccino. And by the way, I've tried my best, but I'm still not a lot of art professional. Well, maybe I should stick with software, which brings us back to our topic. Back in 2018, I was traveling through Australia and after a while had a small business idea about a team management software. I knew it will be shipped as a web app, which, like quite often, required a reactive UI. I strictly refused to go for the JavaScript single-page application madness again. I suffered way too much the years before. I questioned everything I did in order to create reactive web UIs and had this idea about reactive web UIs implemented in pure Ruby. My goals were shipping appealing reactive web UIs while experiencing high productivity and of course high developer happiness, and that should cause high implementation iteration speed. So I knew I need to get from here back here. And after several iterations and weird implementations, I ended up with something that actually worked and I thought was really valuable. MateStack was born. Back in Germany, I skipped the idea of building this team management software and together with 2 friends founded a small tech startup. We wanted to build an open source business on top of MateStack. I thought the value of MateStack could partially monetize looking at something like Sidekick. Well, that didn't work good enough on a business level, but it worked very well on a technical level, validated in a bunch of real-world applications built on top of MateStack until this point. So, business was not running that smooth, and I realized that growing a company and creating an ambitious open source project at the same time is not my type of tea. So just a few months ago, I therefore decided to shrink down the company to myself and put myself on a mission. Grow a team of core contributors in order to build a sustainable UI toolset for Rails developers worldwide. But before we talk about open source, and you, my friend, how to get from here to here? Well, let's say hello to MateStack. So, based on a strong foundation, Rails with routing, controllers, models, and so on, we want to create a beautiful reactive web UI. What do we need? Well, we somehow need HTML. We need some JavaScript, and finally, we need styling. Instead of writing HTML, we will create HTML structures with pure Ruby. Instead of writing JavaScript, we will compose pre-built reactive components in pure Ruby. And instead of writing CSS, we will compose pre-built styled components in pure Ruby. So let's start with the first building block of MateStack. HTML structures implemented in pure Ruby. First of all, we somehow need to render HTML in the browser. That's basically how web browsers are working. But we can choose how to create this HTML. I therefore ask you that question. What do you prefer? ARB or pure Ruby? HAML or pure Ruby? Slim or pure Ruby? Or in general, a limiting templating engine syntax or pure Ruby unlocking all features of this powerful language? Well, think of the HTML structure of a Bootstrap card component. And now watch how the same structure may look like in pure Ruby. MateStack's basic Ruby DSL is not abstracting anything, still as flexible as pure HTML. Heads up, we will abstract things in a bit by purpose. So see, some amount of code, the same amount of code is still required, yet. But we're crafting UI code in beautiful Ruby syntax rather than using a templating engine syntax, which soon unlocks some cool features. And pure Ruby might already be more enjoyable to write compared to writing HTML syntax. So somehow MateStack's rendering converts pure Ruby into HTML. But where to put this code? We put this code in a self-contained Ruby class, which we call a MateStack component. When a new instance of this class is called, the main response method will return the desired HTML string. So let's immediately start refactoring a bit. We can simply break out of deeply nested HTML structures and create a flat implementation. So we end up splitting UI code into small, semantically separate chunks by just calling Ruby instance methods. Doing this, we increase readability and maintainability of our implementation. And that's just a very simple example. Can you imagine how powerful that is when working on complex UIs? You can use all kinds of Ruby's language features to craft your HTML structure. Let that sink in. And now let's make it a bit more usable, reusable. Components may take required or optional options in order to dynamically render injected content. You just define a simple component API at the top and use the injected options across your component. Components may take blocks or even name slots as well, making them even more flexible. We see an example on that later on. And how do we integrate this Ruby class in a Rails app? Well, we basically have two integration modes. We can use MateStack components on Rails views, or we can use MateStack components on MateStack pages. That sounds interesting, but let's start with calling MateStack components on existing Rails views. We simply call our component class and pass in required and optional parameters. In this case, title and content coming from active record instance. Or we substitute the complete Rails view with a MateStack page. Same principles as seen on components. We create a class, a main response method, and may use all kind of custom instance method helping us to structure our implementation. And for sure, we can call our component here as well. In order to integrate this MateStack page into Rails, we simply telling a Rails controller not to render Rails view, but a MateStack page instead. MateStack therefore can progressively replace or live side by side with the UI layer of Rails. All other concepts like routing, controller-based authentication or authorization, and so on stay untouched. We've not talked about reactivity yet. Well, MateStack can actually be used with all kinds of reactivity systems, or none if you wish. If you don't need reactivity, well, you're done. But we want to have one holistic solution for creating reactive UIs in pure Ruby. That's why we decided to ship an optional reactivity system based on Vue.js within MateStack. So let's have a look at the second building block of MateStack, pre-built reactive components composed in pure Ruby. Why won't you do something like that? Well, 90% of required reactivity is based on similar patterns. I've created a small JavaScript app showcasing these patterns. So, demo time. Okay, on this little JavaScript app written in Vue.js, I want to showcase the recurring patterns when implementing reactive UIs. So you see a small Twitter clone, and we're going to be able to tweet some tweets. And just have a look. We start at the top. We see two buttons, and with these buttons I'm navigating to another page. So for example, a profile page, and I'm navigating back to the timeline. And well, you see a dynamic page transition, a typical feature of a JavaScript-driven single-page application. On the timeline, you see a form, and if you submit the form with missing input, you will see immediately feedback down here and at the form input. And these error messages came obviously from an active record instance, which is requiring this input here, but it's shown without a full browser page reload immediately after submitting the form. So let's submit the form with the required input. So there you go. So I've posted something, the form resetted itself, and the UI below the form was partially updated, and we see our new tweet. We are then able to increase database column of the tweet, in this case a simple likes counter, and if I'm clicking it, I'm obviously triggering a server-side action incrementing this database saved likes counter, but I see immediately the updated number on the UI without a full browser page reload. So this is also like a typical requirement of reactive UI. Just maybe post something again to have at least some tweets here. Well, when talking about partial UI updates, that might also be relevant to toggle the UI state here and there, just based on client-side things. For example, if I want to do, have to show an inline editing here, and I click on edit, and the UI here, the UI state was toggled a bit, and I see a form enabling me to edit my tweet. I know that's not possible on Twitter, but for the purpose of this example, just want to show you that here, and I'm updating my tweet, and there you go, the UI toggled back. So this is also kind of a reoccurring pattern, toggling the UI state dynamically without a full browser page reload. And while talking about real-time reactive web UIs, is it's always about like synced web clients. So on this demo, we want to sync multiple clients to see immediately when somebody else is tweeting something. So let's see how this is working here. So I have two connected web clients and two browsers, and well, I'm just tweeting something again, and there you go. Both clients were synced, and I'm also able to sync the increments of the likes counter on each browser. And well, sometimes it's might be a really interesting feature to have like lazy loading. So let's assume loading of this list would slow down the initial page speed of this Twitter clone. So we want to be able to lazy load all the tweets here. And if you watch closely, I'm reloading, and you saw like the form was shown immediately with initial page load, but the tweets were lazy loaded. So this speeded up the initial page load in this example. So to sum it up, we have dynamic page transitions, we have reactive forms with reactive feedback, we have partial UI updates, we have UI state toggling, and we have synced multiple clients. So these are all reoccurring patterns of reactive web UIs. And the sad thing is you have to write a lot of JavaScript to get all these things going. Well, let's see what MateSec has to offer when it comes to something like that. Okay, so again, 90% of required reactivity is based on these similar patterns. Why re-implementing these generic features in JavaScript all the time? Why not build and maintain these features once and reuse them across all your apps? Well, we already did it. And you know what? The demo I just showed was created out of these pre-built Vue.js components. I didn't write a single line of custom JavaScript to get all the reactivity you saw in the demo. I used the transition component in order to create a dynamic page transition. I used the form component for a reactive form. I used an async or a cable component for partial UI updates. I use an action component triggering a server-side action and a partial UI update afterwards. I use an onClick component to toggle the UI state somewhere else based on a toggle component. And these are just a few examples how you can compose a pretty reactive UI without writing a single line of JavaScript based on these pre-built components. And the best part, I just used pure Ruby methods within my components or pages in order to call and configure these components. I've really created a pretty reactive UI in pure Ruby. How does that work? Let's review this feature using the onClick and toggle component. Imagine the simple use case. You want to click somewhere on the UI and want to toggle the view state somewhere else on the UI. In MateStack, you would do something like that. You just call Ruby methods like onClick and toggle and pass in required options and a block. They are targeting components like the self-made card component in our previous example, but in this case, this pre-built component knows that it is associated with a Vue.js JavaScript counterpart. As mentioned earlier, the response method of a component or page class returns an HTML string, and each Vue.js component reference, in this case onClick and toggle, triggers the rendering of a special HTML component tag containing the configuration hash like emit hello and show on hello as tag attributes. When this HTML is passed by Vue.js in the browser, the referenced Vue.js components, which are included in MateStack's JavaScript, are mounted and get the configuration hash injected. We then have two Vue.js components up and running in the browser. Additionally, an event hub is mounted, which enables communication between all components. So we defined an UI which will show a button which says click me. And when that button is clicked, the event hello is emitted and then received from the toggle component, which will show its content, in this case a span containing a string hello world. Just like this, the inline edit switch in the demo was implemented. And thanks to specific configuration, specific blocks, in our case the button and the span, you can adjust the behavior and the look of the pre-built reactive components according to your needs. And that's true for all pre-built components, doing way more complex things for you. So let's have a close look at some of these components. The action component is designed to call server-side Rails controller actions from the web browser. Think of the like button we used in the demo. Within your Ruby response of a page or component, you simply call the action component, unconfigure it with a hash containing the Rails controller action path and the desired HTTP method, in this case put. Additionally, you're telling the action component to show a simple button with your specific block. When this button is clicked, the action Vue.js component performs a background HTTP put request towards the specified path, targeting a Rails controller action. The Rails controller action does its thing, and that's it. Let's jump to the form component. In pure Ruby, we're calling the MateStack form component and pass in a configuration hash. This time we're using a helper method as the configuration hash is a bit longer, but we want to keep a clean UI implementation. We're telling the form component to collect user input, in this case via a text input, and when submitted, perform a background HTTP request containing this user input towards the specified Rails controller action. The controller action does its thing and may react with a positive or negative status code. A negative status code usually will contain server validation messages, for example, coming from an active record validation. These errors are received from the Vue.js component in the browser and then rendered next to the relevant form input fields. You saw that on the demo earlier. In our example, we configured the form component to emit an event submitted when the form was submitted successfully. If the Rails controller action responds with a positive status code, the form component emits the event to the event hub, which can be received by other Vue.js components in the browser. Which brings us to the next component, Async. The Async component is designed to perform a partial UI update, requesting fresh content from the server. Think of the Twitter demo. We had a form on top and listed all tweets below. After form submission, the list of tweets was updated without a full browser reload. That's because we configured the Async component to re-render itself on a specific event. When the form was successfully submitted, it emits the event submitted, which then is received by the Async Vue.js component. The Async component then performs a background HTTP request towards Rails controller action, and the controller action re-renders the UI on the server side and just sends back the relevant part of the HTML to the Async component in the browser. The component can now perform a DOM update, rendering the fresh HTML just sent from the server. That re-rendering was based on a client-side event coming from the form. But in the demo, we saw synced web clients. How does that work? The good news are, Async doesn't care where the event is coming from. Thanks to a super simple action cable integration, events can be broadcasted from the server to all connected web clients and there pass through to MateStack's event hub. And then the Async components on all connected web clients are doing their thing, requesting a new version at the Rails controller action, re-rendering, and sending back only the relevant part. You might ask, why do we need to re-render the whole UI on the server side if we only want to add a new tweet to the list? Good call. If you're into optimizing the partial UI update mechanism, you can use MateStack's cable component. The cable component in this example is configured to append something on an event called new tweet. Well, now we use the action cable integration to not only push a simple event to MateStack's event hub, but render a specific component, in this example, the custom tweet component rendering only one tweet on the server, and push this specific HTML to all connected web clients. The cable component in the browser receives the event and the rendered HTML and will append this HTML to the current DOM. This approach is way more fine-tuned compared to the simple re-rendering mechanism of the Async component, but it requires a bit more implementation effort. For simple use cases, the Async component serves you very well. If you need to take care of computation time on the server and scalability towards higher traffic, use the cable component. And now let's talk about one more pre-built component, transitions. Transition components enabling dynamic transitions from one page to another without a full browser page reload. Well, you need at least 2 pages for that to work. Let's define them. We have 2 Rails routes targeting 2 Rails controller actions, each responding with a different MateStack page. But wait, there's something else. We tell the controller to wrap all page responses in a MateStack app. A MateStack app is therefore something like a Rails layout. Like a Rails layout yields Rails views, a MateStack app yields MateStack pages. An app may look like this. Just like MateStack pages and components, we define a Ruby class and a response method. In there, we're defining a navigation on top, calling 2 transition components in our example, with different paths targeting the Rails controller actions we just saw. And we need this yield telling the app where to yield pages, like these 2. On initial request, the requested page and its app will be rendered together and shipped to the web browser. Vue.js then automatically mounts a page content Vue.js component on the spot where we told the app to yield pages. When we click on the transition Vue.js component, the transition will trigger a background HTTP GET request towards the desired Rails controller action, which will only respond with the HTML string generated from the response of the desired MainStack page. This HTML is then shipped back to the browser and will be picked up by the page content Vue.js component, which then switches the current page with the new one coming from the server. The rest of the layout stays untouched. The transition may also emit events, telling other components to react to page transition events. You saw all kind of generic pre-built reactivity used in pure Ruby. That's actually good enough to build 80 to 90% of the required reactivity of a typical web UI. MainStack invites you to shift your mindset. Instead of implementing reactive features and taking care of front-end, back-end data flow with JavaScript yourself, use MainStack's growing component library and let them do the work for you. The work of implementing JavaScript is already done. But if we really need custom reactivity, what cannot be built with the built-in components, simply add your own Vue.js components and let them live side by side with the built-in ones. So this is how a custom Vue.js component on the Ruby side might look like. You're referencing a Vue component name here, and you create a pure Vue.js component with the corresponding name. And within this Vue.js component, you can do whatever Vue has to offer. Additionally, you might call the Event Hub API in order to communicate with other Vue.js components, either built-in ones or other self-made Vue.js components. Custom Vue.js components are used like all other components and can communicate with all other components through the Event Hub. In this case, we're calling our Vue.js component here next to a toggle component and our Ruby response. And we're emitting an event from our custom component and trigger our toggle component to show its content on when receiving this event. Using this approach, you're able to fill up the last 10% of custom reactivity your app might need, or even not. Sometimes built-in reactive components are enough. Do you realize how much JavaScript hustle can be avoided with MainStack's pre-built reactivity system while still being completely flexible? That's what we call flexible abstraction. You might ask, where is the beauty? Okay, you're right. We've talked a lot about reactivity. So let's talk about the last bit of MainStack, pre-built styled components composed in pure Ruby. Why do you want to use pre-built styled components? Well, how much do you enjoy copy and pasting complex DOM structures and giant chains of CSS classes across your app in order to create a decent looking UI? Do you remember the Bootstrap card component example from earlier? Wouldn't it be cool to have all Bootstrap components available like that in pure Ruby? Well, today is your lucky day. We've already done this. Let's start simple with a Bootstrap button. Just a simple Ruby method and optional params like a specified variant. Et voila, you save recreating growing DOM structures and CSS classes and start implementing a styled UI in pure Ruby. And that's just a simple example. If we review the pre-built Bootstrap card component, you quickly see how one line of Ruby saves you from writing and maintaining 6 lines of HTML containing various CSS classes. And you know for sure that these kind of components are not only used once on the UI. We're not talking about saving a few lines of HTML here and there, These pre-built style components make a huge difference, especially on a growing UI. But you might ask, what if I want to pass in something more complex than a simple string? Well, do you remember me promising you to show how components may also take blocks or even named slots earlier? Here you go. Instead of passing in a string, which should be rendered in the card body, we're now passing in a custom block, which contains a span. This block will now be rendered instead of the default paragraph while still keeping the wrapping DOM of a card. And what if I want to inject multiple custom DOM parts and not only one block? Well, in this case, you should use slots. Following the API documentation of the component, you're basically passing multiple references to your custom methods into the pre-built component. The pre-built component will then render your injected methods, defining a custom DOM on specific placeholders within the pre-built component layout. This approach is super powerful when we're using more complex pre-built components, which brings us to the smart collection. Imagine a pre-built style component rendering a good-looking collection of database items. Applying configurable filters triggering reactive re-rendering of the dataset without a full browser page reload. Applying configurable pagination, enabling reactive browsing through large lists of data, again without a full browser page reload. And additionally enables you to pass in slots called for each row, rendering custom row actions, all without writing a single line of HTML, JavaScript, and CSS, just a few lines of pure Ruby. Too good to be true? No way, it's really working. Call the pre-built component, define the base query, configure pagination, configure columns rendering, configure filters, and finally configure custom action rendering through a slot called for each row. I think it's time for a demo. Before we see the smart collection in action, we should have a look on what's possible to create with MateStack's pre-built style components. This app uses the default theme of Bootstrap. Obviously, you can create your custom themes based on Bootstrap's theming approach to adapt the look and feel to your needs. On this dummy app, we're using the predefined responsive sidebar and predefined page layout components such as page heading or section cards in order to quickly create a reactive, clean and good-looking UI without thinking of any CSS or JavaScript. Easily integratable chart.js components for help us to display data and charts based on the current color theme. We're using styled form components for reactive forms and trigger the built-in toasts for reactive feedback. And then finally, we utilize the smart collection component in order to quickly create reactive paginated table with filters. We can browse through the dataset thanks to reactive pagination or filter the dataset. In this case, searching for a customer with the last name Jacobs. Oops. Through custom row actions, we implemented a delete action asking for confirmation and re-renders the dataset after successfully deleting the item on the server. And if you don't want to display data in a table, you can add your own list rendering through an additional slot while still keeping reactive pagination and filtering. In this case, we're using a slot defining collection item rendering through a Bootstrap card instead of rendering a table. On top of all what you've seen, all Bootstrap version 5 components are accessible as MateStack components in pure Ruby. If you're curious how it's implemented, head to dummy.matestack.io enjoy the look and feel of this little dummy app, and review the implementation in pure Ruby. So wrapping it up now, we've managed to skip writing HTML and enjoy implementing HTML structures in pure Ruby instead. We've managed to skip writing JavaScript and enjoy implementing reactivity in pure Ruby instead, easily extendable with Vue.js if required. And we've managed to skip writing giant DOM structures and CSS class chains across all our apps and enjoy composing styled components in pure Ruby instead. The first two layers are shipped within the open source gem MateStack UI core, and the pre-built styled components are shipped within the open source gem MateStack UI Bootstrap, both available on GitHub. And if you're not into Bootstrap, why not creating a gem for your custom design system which can be reused in all your apps? Either way, I hope MateStack will help you escape the front-end hustle. Good point. We've talked about beautiful reactive web UIs implemented in pure Ruby, but we haven't talked about you. Now it's your turn. Go to GitHub and give MateStack UI Core and MateStack UI Bootstrap a star if you like the project. Follow MateStack at Twitter to get news and helpful tips around MateStack, and head to docs.matestack.io and get started with our Getting Started guide, building the shown Twitter clone step by step. Jump on our Discord server and say hello, share feedback, and get community support. And contribute. Create issues reporting bugs or request missing features. Get an onboarding from me personally and become a member of the core team, and help to build an amazing tool for Rails developers and enable them to have fun again when it comes to building reactive web UIs. I'm super happy to get to know you better and answer any questions around MateStack on Discord in my RailsConf Q&A slot starting April 14, 2:30 p.m. Eastern Time, and honestly anytime on online there. Thanks for listening and have a wonderful RailsConf experience.